Hello students, in this section or rather in this episode we'll be discussing some system of units, and before that we need to make ourselves aware about basic or fundamental units and derived units. What are basic or fundamental units? What are derived units? What are the types of systems which we make use of in representing a physical quantity? So these are the topics which I will try to cover in this particular lecture, right? So let's start with basic or fundamental units. Basic unit. It is also known as fundamental unit. Fundamental or basic unit. Now you are aware, meter, that's the normal unit which we use for measuring length, distance. Kilogram is the unit for measurement of mass, amount of matter. Then second, this is the unit which we make use of in measuring time. So kg, meter, second, these are the units of mass, length and time respectively. These three are known as basic units. Why they are known as basic or fundamental units? Because they can't be derived from any other unit, nor they can be resolved into any further units. So basic units, what will be the definition of basic unit then? Basic units are those units which can neither be derived from any other units, nor it can be resolved further into any other units. So they are known as basic or fundamental units. So kg, which is the unit of mass, right? It is the unit of mass. Meter, which is the unit of length or distance, and second, which is the unit of time. These three are considered to be the basic or the fundamental units of these three basic fundamental physical quantities. They are the three basic units and these are the three basic physical quantities. Now, physical quantity. I am using this term physical quantity. Before we proceed, we need to know this as well. We need to define physical quantity as well. Now look, in junior class again, we have discussed about pressure. You are aware of force, pressure, force per unit area. Right? Force, it's mass into acceleration. Speed, distance over time. Right? Acceleration, change in speed over time. These are various formulas. Momentum, mass into velocity. So, whenever the laws of physics are expressed in terms of some quantities, then those quantities are known as physical quantities. So basically, physical quantities may be defined as the quantities in terms of which the laws of physics can be expressed. Right? So without physical quantities, we can't express the laws, isn't it? So these are the quantities in terms of which the laws of physics can be expressed, right? So these are fundamental or basic physical quantities and their units are basic or fundamental units. So we have discussed basic unit, right? It cannot be resolved any further, nor it can be derived from any other units. So that's basic unit. Derived unit. Concentrate on the term. Derived means obtaining such units from some other units. So derived units, as the term suggests, these are the units which can be obtained either by multiplication or dividing the basic units of mass, length and time. So these are the units which are obtained by the basic units. I'll give you some example, like speed. It is distance over time in one average term, right? So this is the fundamental or basic quantity. Its basic unit is meter. Time, its basic unit is second. So speed, its unit is meter per second. It can be written in this particular manner as well, right? So meter per second becomes a derived unit. It is derived by the division of meter and second. So these are the two basic units, but by dividing these two units we obtain the derived unit, that is meter per second. Another example. Suppose we take the example of momentum. Its formula is mass into velocity. Mass, its unit is kg, velocity its meter per second. So this is another unit which is derived from kg, meter and second. So this is again a derived unit, right? Force, its SI unit is Newton. Now force is mass into acceleration. So SI unit of force is Newton. It is represented by capital letter N. We'll discuss it. Mass, its unit is kg. Acceleration, it is meter per second square. So look, Newton is obtained by the multiplication and the division of kg, meter and second. So Newton becomes a derived unit. Understood the concept now? So there are various examples. You need to understand. Basic unit, these are the basic units. It cannot be derived from any other unit, nor it can be splitted or resolved into some other units. Derived units, they can be obtained only by using these three units, either by multiplying them or by dividing them. That's the simple concept, right? So basic and derived units. Now physical quantities, as we have discussed, these are the quantities in terms of which the laws of physics can be expressed. Now suppose a physical quantity is x. Now how to represent it? Now whenever we encounter a physical quantity, right? When we write a physical quantity, there are two parts, or rather a physical quantity has to be represented by two parts. One is its numerical value and the other one is the unit. A physical quantity has to be always written along with its unit wherever applicable. So suppose x is the physical quantity. The proper representation of the physical quantity is n multiplied by u. N stands for the numerical value. It stands for the numerical value. And u, it stands for the size of the unit. Size of unit. Right? So x is equal to nu. I'll give you an example. Suppose we are talking about a physical quantity which is mass. And suppose the mass of an object is given to be, let us assume it's given to be 5 kg. It may also be written as 5000 gram. Isn't it? 1 kg is 1000 gram. So 5 kg would become 5000 gram. Look, it includes two parts. This can be considered, this numerical value 5 may be considered to be n1. Kg, it's the size of the unit, it may be considered to be u1. This is another system where the numerical value of the same physical quantity is n2, which is 5000 over here, and gram is the unit again for measuring mass. It is unit in some other system, so it can be considered to be u2. That's the size of the unit. So what I mean to say is that this x is constant. So there's an important conclusion. If the numerical value of a physical quantity is smaller, then the size of unit is large. Here, kg is larger unit than gram. Understood now? Nu. If the size of unit is smaller, then the numerical value of the physical quantity must be larger, and vice versa. 5 kg is equal to 5000 gram. Obviously, 5000 numerical value is much greater than 5. But size of the unit kg must be greater than gram. Then only they can be equated. So whenever the numerical value of a physical quantity is large, then the size of unit must be small, and vice versa. So any physical quantity is represented by this. It can be converted to any system of unit, which we'll be discussing right now, but the physical quantity remains same. Along with unit, it is represented by n into u, and n1 u1 should be equal to n to u, both being constant. Now we can discuss system of units. There are various system of units. CGS system, FPS system, MKS system, and last but not the least, SI system, which is the most important one. So we'll discuss these four system of units. So first is the CGS system. CGS system, right? It is a system which was developed in France. It is basically a French system of unit. And as it's pretty clear, it is a system in which centimeter is considered to be the fundamental unit of measuring length. Gram is considered to be the fundamental unit of measuring mass. And second is the fundamental unit for measuring time. So CGS is a French system of unit, and in this system centimeter, gram and second are considered to be the basic or fundamental units for measuring length, mass and time respectively. It is a metric system. Second is FPS system. FPS. It is a British system of unit. In this case, F stands for foot. It is the unit which is used to measure distance. P stands for pound, which is a unit for measuring mass, which is the amount of matter. S obviously stands for second. So FPS is a British system of unit which makes use of foot, pound and second as fundamental units to measure length, mass and time respectively. Nowadays, this system is not used much. It has become obsolete. Third is MKS system. It is a system which is closely related to CGS. It is also a French system of unit. In this system, mass is measured in kg. The length is measured in meter and time is measured in second. So it is a French system of unit in which meter, kg and second are considered to be the fundamental or the basic units of length, mass and time respectively. It is also a metric system, and most importantly it is a coherent system of unit. It is a coherent system of unit. MKS is a coherent system of unit. What I mean to say is that coherent means, just now I have explained, Newton, SI unit of MKS or MKS unit of force is Newton. It is, just now we have discussed, kg meter per second square, right? So the Newton, which is the MKS unit of force, is represented by either multiplying or dividing the fundamental units of kg, meter and second without the introduction of any numerical factor. Here there is no need of introducing any numerical factor, right? So that's coherent system. So a system is said to be coherent if the derived units are obtained by the multiplication or division of the fundamental units without introducing any numerical factor. So such a system is said to be a coherent system of unit. Fourth one, which is the most important one, it is SI system. It is again a French system of unit, and the acronym SI, it stands for, actually it is a French term, Système International D units. Actually, acronym SI stands for Système International D units. It's a French term. SI may also be written as Standard International, but actually it is Système International D units. Now look, it is the latest system of unit, and what's the need for developing the SI? All the previous three systems which we have discussed contain three basic units. Now physics is so vast. There are various different branches of physics in which different new physical quantities were required. So in order to include other basic units, this system was introduced. So it is a French system of unit, and it contains not 3, it contains 7 fundamental units. Along with that, it contains 2 supplementary units, which we will be discussing right now. So SI is also a coherent system. SI is also closely related to MKS and CGS system, and it is also a metric system. So SI is the system which we prefer. We will discuss the reason for that as well. But now let's discuss the units which are included in SI. Right? Let's start with the basic units. Basic or fundamental units. This is the physical quantity. They are the basic physical quantities or fundamental quantities, and their units are known as the basic units or fundamental units. Okay. First one is, as usual, those 3 will be included over here as well. That is mass, length and time. These 3 are common in all the system of units, right? So mass, its SI unit is kg. Length, its SI unit is meter, right? Third is time, its SI unit is second. These 3 are common in all the 4 system of units. These are the basic quantities and these are their units, which are the basic or fundamental units. Fourth, temperature. There are various units for measuring temperature, but the SI unit of temperature is Kelvin, represented by capital letter K. Current, electric current, its SI unit is ampere. This is Kelvin. Temperature. Current is ampere. Amount of matter. It is mole. And 7th one is luminous intensity. Luminous intensity. It is candela. So these are the 7 basic fundamental quantities in SI, and these are the 7 basic or fundamental units of SI, right? Mass, length, time, temperature, current, amount of matter and luminous intensities. So these are the physical quantities which are included as basic physical quantities in SI system. As I told you, there are 2 supplementary units as well. There are 2 supplementary units as well. The first supplementary physical quantity is plane angle. Plane angle. The SI unit of plane angle is radian, which is represented as RAD. It is this first supplementary unit is radian, and the second one is solid angle. This is a term which we make use in 2 dimension. In the case of a circle, we consider plane angle, which is the plane angle. Solid angle, it's a 3-dimensional thing. Consider a sphere. Imagine yourself to be at the center. So if you consider a small portion of the sphere, and if you connect the lines on its edges to the center, then it should appear in the form of a cone. So the angle formed in the space, that is known as the solid angle. So it's a 3-dimensional thing. It is used in 3 dimensions. Its SI unit is steradian, represented as SR. So we will define each and every unit. Then we will also discuss the importance of SI, why SI system is preferable as compared to the other systems, isn't it? So SI is the French system of unit, which is the most preferred one, It includes 4 other basic units as well, in addition to those 3, mass, length and time, and in addition to that it contains 2 supplementary units as well. Now force system, consider MKS and SI. SI is just the extended version or modified version of MKS. So, logically it can be explained like this. If this is MKS, then the bigger circle will represent SI. I hope you have understood this illustration, isn't it? 3 quantities are common and it will contain another 4 quantities, which are time, temperature, current, amount of matter and luminous intensity. So please go through these topics thoroughly, right? So in this lecture what we have discussed was basic units, derived units, right? Then we have discussed how to represent a physical quantity, and then we have obviously discussed the system of units. So please study well. We will discuss the other section in the next episode.